Right, hi everybody. So we're going to take a couple moments here. We're going to solve this rational equation, 2x minus 16 over x squared is equal to 0. The first thing I want to point out here is, again, there is a possibility for a value to be undefined or an answer here to be undefined. So I just want to take a quick look and point that out here. So remember, when you've got a over b, and we're gonna solve this here, it's really important to me that when I have an equation like that, that I identify values of the variable that are going to force the denominator to become 0, which would be an undefined value here. So we don't want the denominator to go to 0, okay? So in this particular case here, when I take a quick look at this, there's a term here that has a denominator, and there are a couple of ways that you could actually approach this problem. I could combine those two terms here, right? I could treat this as 2x over 1, come up with a common denominator, put those together. Whether I do or I don't, the denominator in this case is going to be x squared. And I'm interested in what the value of x is that's going to make that equal to 0. So I take the square root of both sides, and I get this square root of 0, which is just 0. And so what we know here is that when I solve this equation here, 0 is not an acceptable answer. 0 causes the expression to be undefined. Now, when I come back to my equation, when I take a quick look at this, what I want to do here is I want to get rid of the rational part of this equation. It's like when you're solving a trig equation, one of your first steps there is to get rid of the trig. Like if you've got an equation with a sign in there, someplace the sign of the x variable, at some point you're going to want to get rid of the trig. When you're solving a quadratic equation, not quadratic equation, what you want to do is you want to get rid of the quadratic at some point. Okay, you can do it by factoring or square rooting or whatever, but that's the goal here. So in this case, I really just want to get rid of that denominator. Okay, so I'm going to multiply by that common denominator, which in this case is just going to be x squared, and that is going to get me 2x cubed minus, and then in that second term there, the denominator is going to cancel with that x squared. So it's going to be minus 16 is equal to 0. Okay? And now this is the equation I'm going to solve. Now, I can do that so long as I remember that my restriction here is that x cannot equal 0, because right now I'm looking at a polynomial, and that polynomial does not share that restriction. Okay, right now looking at 2x cubed minus 16, I mean, don't worry about the equals 0. If I'm just looking at that expression on the left-hand side there, I could put 0 in there. Now I can see clearly right now that that isn't a solution to this equation. Okay, but that is something to consider here. So now what we might do here is factor out. Actually, you know what? I'm going to tell you what I'm going to do. I'm going to bring that 16 over. I factored before in another video here. I'm going to bring that 16 over. We're going to divide both sides by 2, and I'm going to get x cubed is equal to 8. And when I take the cube root of both sides, okay, to remove that exponent there, I get x is equal to the cube root of 8. And in this case, the cube root of 8 is just 2. I don't need to worry about the plus or minus that you would normally see when I take a root here, because I'm not taking a square root or a fourth root or a sixth root or something like that. It's not an even root. It's an odd root. And so the signs aren't an issue for me. If it was the cube root of negative 8, my answer would have been negative 2. In this case, the cube root of positive 8 is going to be positive 2.